That's good. So I'm going to use the ruler that we drew earlier. So X is over here and Y is over here. So we can draw on, mark on Y, and actually I can extend, we can draw on the outer edge of this part of the map too. So there, that's fine. So then we can put on all of the information just like we did in class, and hopefully you realise. So A10, we can take that to that line there, and I'd recommend starting this with pencil in fact. So that's A10, which is the contact between mudstone and greywacke, and then A9 is halfway between there, and that's also B10, so we have to move it up for B, which is there. Then A8 is over here, and it's also B9, which is there, and then B8 is down here, and then we get into the faults, so that's F11, which is here, F10, which is here, F9. Hopefully you can see that the dip of the fault is much greater than the dip of the beds, which is what we'd expect because our structural contours were much closer together. And then we get to A8 on this, on the southern side of the fault, and that's the same as B9, which is up there, and A7, which is here, and B8. Of course, you'll spend much more time doing this and do it in a much neater way, but that's basically all the information you need. So then I draw on the fault to start with, so that's all these dotted lines here, and hopefully if you've done it right you can draw a straight line through there, and then maybe extend that up into the sky as well to get your fault plane. Then we had the beds for A, so we can draw a line through those ones as well. So that's the contact between mudstone and greywacke, so that's there, and then the contact between sandstone and mudstone, which is here, something like that. So we can label that, so that's greywacke, that's mud in there, and then the stuff on top is the sandstone, mudstone, so that's mudstone. Okay, and then we've got the same on this side as well. We can draw between the 2 points. Hopefully you can see the dot in there. So I'm just going to draw that to the fault plane, and then the same there as well. So we've got exactly the same on the other side of the fault, so we can see the beds have been displaced. So it's greywacke, mudstone, sandstone. I spelled sandstone wrong, that's brilliant. Sandstone, cool. So hopefully from that simple cross section, that gives you quite a lot of information about what's going on. So we know from our calculations that angle is 26 degrees, all right? We can now see how the fault has displaced the unit, so we can see that these units have been displaced vertically relative to these units, so we can draw those symbols onto the fault, and we can say that this is a reverse fault. So the movement is with a thrust fault, essentially, for a low angle. So it's a thrusting sense of movement. So the type of fault is a reverse fault. We can also now label on our map as well that the hanging wall, this is the hanging wall on the south side of the fault, and the footwall is up here. we can tell that from there. So, and we had some more information on the scale, on the ruler that you drew earlier. So we also know that the unconformity is at 1100 here as well. So we can mark that on. Unconformity there at 1100, and the unconformity is at 1000 here as well. So we can also draw that on, and you can see that it's got a slightly different dip to the beds below, which makes sense again. So we can draw that on, and we have to do a little bit of interpretation here. So you can see there's a slight change in the angle, and at some point these units would start to interact again because it's an unconformity. So we may interpret and say that unit comes into contact with the other unit there, to give some interpretation for the unconformity. So that's the sandstone, and then above there, so the unconformity is there, and then we've got the siltstone on top. So that, if you can produce something, and you can do the same for the units below. If you pick out the different unconformities, I think you can get that information here. For example, the unconformity goes, but a 1000 there. That's 1000, 1000. So you can plot that point on, and do the same where else it goes through as well, if you look carefully, and then you can put that on for the other side as well. And if you can produce something like that with the strike lines and structural contours on, and a cross section like that, labeled with some information with the sense like that, and also if there's any kind of folding that you can highlight and put into your maps, that would be great. In this case, we're just concentrated on the faults, and you might want to think about how you draw cross sections and whatnot to encompass the folding as well. But that would be ideal. And so, of course, also then you can start to tell information about the displacements of the different units. You can draw on, for example, where the contact A, mudstone and greywack, which is up here, and then the same contact on the north side of the fault, which is over here as well. So you can draw some information there to start to figure out things like the down throw, and the amount of down throw on the fault, the amount of stratigraphic down throw, and the heave, which you, again, remember is the horizontal distance. So if you can get all of that information, which you should be able to get from a cross section like this and from that would be fantastic. And you can do it in a much neater way than I've done here quickly, and hopefully you can do that relatively quickly and simply. So that's the guide to how to make how to tackle one of these problem maps. Hopefully that's useful. Thanks.